This is Math 6, Lesson 3-8, the distributive property. The distributive property shows how multiplication affects addition or subtraction. Let's look at the following two rectangles. We're going to find the total area of the two rectangles. One is 4 by 5 and the other is 4 by 3. One way we could find the two areas is to find each area separately and add them together. If I was to number this rectangle number 1 and number the second rectangle number 2, I could find the area of rectangle number 1 by taking my length, 4, multiplying my width, 5, which is 20. And then I could take the area of the rectangle of number 2. My length is 4 and my width is 3, which is 12. If I add those two together, I get a total area of 32 square units. Because it's an area, it has to be in square units. Okay. Or the second way I could do this is I could combine the two rectangles into one rectangle and find their area. If I have two rectangles that are, one is 4 by 5 and the other is 4 by 3, since they have the same dimension right here, I could make them one giant rectangle. I could have a rectangle, then instead of 4 by 3 and 4 by 5, this would be 4, and this would be 8, because 5 plus 3 equals 8. So if I have a rectangle that's 4 by 8, I could take my area and take 4 times 8 and get 32. You'll notice we have the same answer for both rectangles. Okay. This shows us different ways to find the sum of the area of two rectangles. And this is an example of the distributive property, which combines multiplication with addition and or subtraction. The distributive property basically states that if you have to multiply something by a sum or a difference, you can multiply and then add or subtract, or you can add or subtract and then multiply. And I've given you some examples of the distributive property here. I could have 3 times the quantity 2 plus 6, which means I could add the 2 and the 6 together first and get 8, and then multiply that by 3 to get 24, or I can multiply the 3 times the 2 and get 6, and the 3 times the 6 and get 18, and 6 plus 18 is still 24. Yes, so it's just the way in which you look at the distributive property. This box is important, but don't get all hung up on it. It will make more sense when we start playing around with it. You can use the distributive property to multiply mentally. I do this a lot. When I try to multiply numbers together, I don't think in my head how to line them up and add and carry and this and that. I think of ways to use the distributive property. So if I'm looking at 47, my brain is saying, wow, 47 could be 40 plus 7, or it could be 50 minus 3. I don't care. I happen to do a little bit better with addition than I do subtraction, so I'm going to think of 5 times 47 as being 5 times 40 plus 7, because 47 is 40 plus 7. So if you think about this, that means I could either, remember the distributive property says I could add 47 together first and then multiply it by 5, or I could separate it and say 5 times 40 plus 5 times 7. I know 5 times 4 is 20. Add the 0 to get the 400. I get 5 times 40 is 200. And 5 times 7 is 35. And 200 plus 35 is 235. Not 2035, 235. This is an example of using the distributive property. You've probably done this before, you just didn't know what it was called. Whenever we manipulate numbers like that to try to make our computations a little bit easier, you're using some form of algebra. It's just that you probably have never been given a name that goes with it. Let's look at number 2, 30 times 104. Okay? I'm thinking of this and I'm like going, 104 is the same as saying 100 plus 4. So I could rewrite this as 30 times 100 plus 4. The distributive property comes from the word distribute. When I distribute papers to every student, that means I go around the room and give every single student a paper. I need to distribute the 30 to everything that's in the parentheses, both the 100 and the 4. So, excuse me, 30 times 100 plus 30 times 4. 30 times 100 is 3,000, plus 30 times 4 is 120. So 3,000 plus 120 is 3,120. Now, yes, you could get the same answer by taking 104 and multiplying it by 30 the old-fashioned way. I'm not trying to make your math more difficult. I'm trying to help you to understand that you can expand numbers and collapse numbers differently so that when we get into algebra and we have a whole bunch of letters, you will know how to multiply them because there's no other way to multiply them except to use the distributive property. Let's look at this next problem. 9 times 199. I'm thinking to myself, wow, 199 is 200 minus 1. So I'm going to use 200 minus 1. So I'm going to have 9 times 200 minus 1. 9 times 200 minus 9 times 1. That's basically what I'm doing. 9 times 200 is 1,800. 9 times 1 is 9. 1,800 minus 9 is 1,791. I can do that much better in my head than I can multiplying 199 times 9 in my head. And this is just the beginnings of the distributive property. It's probably the first time you've been introduced to it, so it's probably a little bit confusing. Don't let it get you hung up. Just work through the process, and the more that you do it, the more familiar you'll become with it, and the better you will get at it. Let's look at some other problems. Word problems in which we can apply the distributive property. Let's say a student bought 4 tickets that cost $5.50. What was the total cost of the tickets? Instead of sitting here and using the old-fashioned way of taking $5.50 and multiplying it by 4, my brain thinks, oh, 4 times $5.50 is the same as saying, basically I'm having 4 times $5.50. And $5.50 is the same as saying $5 plus 50 cents, right? That's $5 plus 50 cents. So if I multiply that by 4, 4 times $5 plus 4 times 50 cents. 4 times $5 is $20. 4 times 50 cents is $2. So I look at this and go 20 plus 2 is $22. So a student bought 4 tickets that cost $5.50 each. Okay. I'm looking at this going, oh, the total cost of tickets is $22. Now there's more than the way I just showed of figuring this out. This is just one of the ways, and we're just practicing this way at this time. Don't forget to put your dollar signs. One more problem. A local bookstore charges $2.80 for each used book. What is the charge for 5 used books? So if we're going to multiply 5 times $2.80, that's the same thing in my book. I could either do this by subtraction or addition. Like I said before, I'm slightly better with addition than I am with subtraction, so I tend to add whenever possible. So I'm thinking of $2.80 as being $2 plus 80 cents. So if I multiply that by 5, that means I'm taking 5 times $2 plus 5 times 80 cents. 5 times $2 is $10. 5 times 80 cents, 5 times 8 is 40, that makes $4. So if I add this together, 10 plus 4 is $14. So the total cost of the books will be $14. This is just one of the ways in which we can use the distributive property. We will be looking at various ways to use the distributive property throughout the rest of this school year. So please, just be patient with it and work with it, and the better you get at it, the more you do it, the more familiar you'll become with it, and you'll begin to enjoy using the distributive property.